Very good morning and salam sejahtera, ladies and gentlemen. Thank you for coming to attend this session this Saturday morning. Although the traffic is good, but I think it's still an effort to be here. I appreciate that a lot. I would like to also thank you, Dr. Tan Lokman, for coming over to present and to support this event this morning. So without further ado, I will start to play a video to introduce who we are as a company, and also there is a video on a new product from BlueScope Steel.
In the still rapidly developing nation, new buildings sprout each day as a sign of advancement of society, both in technology and aesthetically. Swissmar has been leading the total solutions provider for roofing and wall cladding in Malaysia. Equipped with the highest technological support and innovation, our team put great care in our work, aiming for total customer satisfaction by advanced research and fulfilling the needs of our clients. Swissmar guarantees everlasting returns for stakeholders, while also providing precision manufacturing along with customized fabrication, creating endless possibilities. Our services include on-site production, providing installation training, craftsmanship quality, engineering and R&D, technical and architectural consultation, receiving multiple award-winning titles such as the Brand Laureate Best Brands Award 2015-2016, Sinchu Business Excellence Awards 2016, the Brand Laureate Best Brands Award 2016-2017, the Brand Laureate Best Brands Award 2017-2018. Swissmar offers sustainable customized solutions using different materials such as aluminium, stainless steel, copper, titanium zinc, TPO or PVC membrane that is FM approved. Most importantly, working in strategic partnership with NS BlueScope Malaysia for solutions in color bond steel. Also not limited to specialized projects being public amenities and infrastructure, commercial buildings, industrial buildings, residentials.
Our company philosophy is to provide products and services of the highest quality with sincerity and integrity.
With high-quality materials and top-notch service, we are one of the top providers for the industry with a guarantee of satisfaction and excellence in our name. Swissmar, your innovative and trusted total solution provider for roofing and cladding. In the still rapidly developing nation,
Okay, those are the two videos. And just to summarize from our corporate video, as a company, we provide total solutions for roofing and cladding. So what do we mean by total solutions? We actually do design of the roof system. We manufacture it, our products, our factories in Chalam, and we can also do installation work. We are sometimes nominated as a subcontractor for the job, and we also take on as a domesticated subcontractor in certain projects. So in designing the roof system, first of all, we have to understand your project needs or your technical requirements. For example, the thermal insulation, the U value calculations. Today, it is mandatory that you need to comply with a certain thermal value, which I'm going to share later. Then we also have software to assist in developing a roof system to meet acoustic STC value. That will be another topic on its own. Gutter downpipe sizing, we have software. We can also help to do a quick check on your design if you need that. Shop drawings, this is one of the key points. In any projects, in order to be executed well, shop drawings is key. So we provide shop drawings, and having understood all your needs, then we will customize the roof system. Material options. In Swissma, we provide a very wide range of material choices. So from colorbond steel, and zinc from bluescope steel, titanium, zinc, copper, stainless steel, aluminum, and even TPO membrane. You have seen some of these projects in the video. So for coated steel, we work as strategic business partner with bluescope. So we only buy and sell coated steel from NS bluescope. We carry a very wide range of profiles. Here is our architectural series. We have the double weld standing seam, winkle weld, snap weld, zip weld, cassettes, dark metal tiles, membrane, and these are. And we also have a Sanko roof series. I will not go into this product because this is just to let you know that we do carry a very wide range of profiles. So what I like to highlight among the architectural series is the Swissma double weld standing seam. You can say this is our signature product. Just like a restaurant, they have a signature dish. We have this as our signature profile. So why is this so great? Because it can cover any shapes or geometry. So this profile can be tapered and curved, hence is unlimited ability to cover any forms. Next, we have the Sanko roof series. Sanko is a Japanese brand that has collaborated with us as a partner since 1974, when Dr. M brought in the first wave of Japanese FDI. So in Sanko itself, we have, again, a very wide range of profiles. This is the most commonly used profile, the Sanko grip deck, which is what I'm going to refer to as a clip lock tab in my technical sharing. And we have very unique profile like seam lock, which is very deep and is concealed fixed. You saw the video on the side forming, that is the profile. Very good for long length, low pitch roof. This is the deepest profile you can ever get. Looks like a gutter, but it is a profile that is so strong that it can even span 11 meters. You don't need close support spacing. So just to showcase some other projects, the KLIA2 projects, we have the Sama Square using a colorbond material, Satir City Mall, IY City Mall, another mall, KSL Esplanade. This is another Satir City Convention Center. University Malaysia Pahang, private bungalow in titanium zinc. Another private bungalow, mass housing, another one, hangar, There are hangars. This is recently completed for Air Asia. This is a factory up north. This is another factory, award-winning factory as well. This is another, these are warehouses. This is Hing warehouse. This is logos. There are a few of these multi-story warehouse in the market now. We have done this as the first logos in Ampang. And also now is a trend for a lot of detached factories in the market. So that's a quick sharing about who we are. Thank you. So now I'll move on to do my sharing on some of these innovative roofing for architects, and I like to share from experience some design elements and also what to look out for at the site. So this is just a brief content. The first thing is nowadays I think all of you are already aware that you need to have sufficient insulation to meet the UBBL Clause 38A. Then I have just to share about oil canning, something that you can't avoid, and some flashing details, and the use of proper tools, and some sharing of customized shop drawing details. And lastly, some do and don'ts, which I think is important that everybody knows. Okay, how to construct metal roof to meet the UBBL Clause 38A requirement. It started from a standard from MS 1525-2680 for residential, and then now it's been adopted in the UBBL. So this is an extraction of the UBBL standards, and what it says is for lightweight roof below 50 kg, you need to have a U value of 0.4 watt per meter square Kelvin. For RC roof is 0.6. So a very simple formula to share. So it's just 3 parameters. First, the K, the thermal conductivity, which is a material property that you need to be aware. Then you got to work out the thermal resistance, which is material thickness over the K value. And then, tada, your U value is already achieved. Just a simple formula. So this is an example of what you get from the data sheets from a supplier. This is a fiberglass wool. They have this K value, see, 0.0366, all right? Then I'll share with you what is from rock wool. These are the 2 typical mineral wool that you use for insulation. Here is 0.036, so maybe 360. So the difference is what you get, R value of 1.39, previous 1.35. So there is a slight difference. Okay, this is a simple Excel kind of file that we use to calculate your U value. So again, I'll explain the D is the thickness of your insulation. The lambda is the K value. And then the R is your thermal resistance. So the higher the R, the lower the U. You need to achieve a minimum 2.50 R value to get the 0.4. So these are guidebooks we also use. This is developed by RIMM and GBI. So they have developed data to capture the R value of air, practically. Okay, we know air is also an insulator. Of course, the best is still vacuum. So before that, there is difficulty, or there's a lot of confusion on what is the R value coming from air gaps. So this is a table from those MGBC to develop the R value. So on this side is the roof pitch. That side is the air gap. Okay, the blue row on the top header is the air gap. So for example, the one highlighted in yellow is actually showing a 50 mm air cavity or air gap for a roof pitch, low roof pitch, okay, 5 and below. So this is also coming from the same source. They also have inserted a value to attic space. So when you have a roof with ceiling, this is where you can capitalize on to get your R value. And this is ASNZ research value. So there are all different kinds of areas and where you can sort of extract your R value. These slides, I actually put it up because this bubble fall, any of you have used bubble fall out there? It's a type of insulation. It started off for more like packing, and then it went on to into roof insulation. Why I want to show this is there's a lot of misleading or misguided information on this use of bubble fall. So bubble fall by itself, just like normal foil, this is 10 mm thick, it just traps some air there. The R value is only 0.118 nominal, very low R value. So you put a normal fall and replace with bubble fall, it doesn't do magic. It just increases the number by slightly. But in the market, some of the approach made using bubble fall is that they use the R value of 2.289. You see the difference? I've seen calculations, submissions done using this kind of value. So this value, although is correct, might be in the catalog, but you must understand that this value is derived from a test that has got air on top and below. That one is how you normally apply it. There is no air on both sides. When you have air cavity on both sides, 50-50 or 40-60 or whatever ratio, your R value increases tremendously. So today I'm going to share, there's a lot of calculations you look at, but fundamentally, how do you construct a roof to achieve what is stated? If there's no air on both sides, your R value is 0.18, and if you use that 2.28, is wrong. You will not achieve. So typically there are two types of roofing system we call. One is single skin, the other one is double skin. Means 2 layers of metal roof. So for single skin, in the past before UBBL, most of the buildings are insulated this way. You just have a layer of 50 mm mineral wool, and then you have your fall, and then that's it. Most of the existing building, factories and all, were done in this system until UBBL came on board, and this will not fulfill that requirement. So what do? You need to increase your insulation. Here, approach number 1 is we recommend 100 mm thick mineral wool, and then you compress to 85. Why compress to 85? Because the calculations says that all you need is just the 85 mm thick to get your R value, to get your U below 0.4. So if you put 100, of course the R value is better. This one is like cukup makan. And there is a very good reason why we recommend to use 100 and let it be compressed, and that is to achieve rain noise dampening. Because metal roof, there are two main concerns. There's a heat and there's a noise. So if you address the thermal insulation without addressing the noise, then it's not a holistic solution. So I'll just quickly show you how it's constructed for a single skin. That's the purlin. You either put a mesh or you don't, because today the foil is self-supporting. Then you have your foil, aluminum foil. You got to use those non-tearable foil, not the paper foil. Then this is what we call the subgird. You need this subgird to achieve your consistency of your insulation depth. The system calls for 85 mm minimum thickness of the wool. So how do you construct to ensure that you always have the 85? So this is how it's done. This top hat is 85 mm tall. All right. Then we add on a C. This is just one approach. To us, this is a hybrid approach. Another approach is use a continuous top hat. Right. The cost will be very high, but it's more stable. Then in the market, a lot of them are using just a Z section, a Z or the Z. But the Z is the least stable among all the system. So here, then you lay your wool 100 mm thick. It's either one layer or two layers of 50. And then you install your top skin, your roof system. So when you install your roof, the 100 mm thick wool will be compressed down to 85. You can't go below 85 because it's been restrained by the subgird. Then double skin is pretty much the same, right? Except your first layer, instead of a foil, you have I'll just show you. Instead of the foil, you have your deck, a metal deck. Then you add on the subgird again. Usual, same stuff. Then here we put a foil here. The foil doesn't contribute to the R value. It's there as a vapor barrier. Okay, if you put a bubble foil there, you don't get the 2.8. That's the biggest mistake. Then you finish up. Okay. So there are so many ways to construct a roof system just to meet the U value. I've been asked by architects when they have a so-called VE submissions, is this okay? Does this meet? So first we look at the calculations, then most importantly, I don't look at calculations alone, I look at the construction, how you construct. So this is another approach. Air is free. So why not capitalize on what is free? So here we have 50 mm thick uncompressed wool sitting on the underliner metal deck. Then our top hat, or this case, I just purposely show the Z as an option, is 100 mm tall. So your 50 mm wool is below. What you get on, then we install another layer of foil on top of the subgird before we install this metal roof. So what we get is, we have a 50 mm cavity we call the reflective airspace, which is this, right? There is a R value of 1.124. This is reflective because to be reflective, you must have a foil. Without the foil, it's non-reflective, and your value is going to be very different. So just to blow up, so this is the degree, 0 to 5. For a 50 mm cavity, reflective airspace, your R value is 1.124. So that's the calculation. You have your reflective airspace, 1.12. Tada, you get your 0.37. Now, like I said, MGBC, they have, or the GBI, they have this attic space R value. So if you have this building, for example, if you have a ceiling, a residential house or project, unlike a factory where you have a ceiling, you have an attic space where you have air. So In this case, we only need a 50 mm thick wool, and combined with the R value from the attic space, we are able to achieve that U value to be 0.36 even. Now the key point about this is, I've encountered again and again many times, this calculation is submitted, but you don't know how they construct. And I have even a project case where we submitted a mock-up with a ZAC. Why a ZAC? Because we have to maintain 50, right? It cannot be less than 50. So to maintain the depth of 50, you need a ZAC to control. So a lot of projects, they just do this, just conventional 50 with the fall, magic, no ZAC. No ZAC. Can that achieve technically without a ZAC? You can't. And there are projects done that way, and I'm sad to say, this is due to lack of understanding. The calculation shows 50 mm with the attic R value, but the construction does not ensure you have a 50. It's compressed. So that system failed to achieve the design intention. So this is what I like to emphasize, because do ask the supplier to provide a mock-up. Right? I have even a case where the final conclusion is Swissmile to achieve U needs ZAC. Company X don't need ZAC. I mean, what kind of conclusion? And that was a real life example. So it's due to lack of understanding. So then again, there is a AAS and ZAC standard. I'm not sure whether GBI is going to recognize this. They have a fantastic R value for the surface firm inside, 0.8. Normally this value is 0.17. So again, you got to look at the calculations, and you got to ask where they get the value from. It's just cannot plug any numbers. So this is how it looks like, the one with the 50 mm air cavity. So this one, like I say, it meets the U value, but there is no rain noise damping. So you have a U, but you do not address your rain noise. So then again, the compression one, 100 to 85, you do address, right, some decent rain noise dampening. That will give you a more holistic solution. So then again, non-self-supporting metal roof, single skin. Non-self-supporting are the architectural profiles like this standing seam. All right, standing seam profile is just a profile that is flat, like you can see, can be 530, 25 mm wide with 2 upturns. So it's practically, like layman said, it's a flat sheet, right? It's a flat sheet. So when you have this kind of profile, there's no corrugation, there's no strength. It's non-self-supporting, right? When you have no strength, you have non-self-supporting. That's why we call it non-self-supporting. So this is how it's like, why it's called seam. It's double seam, like the Coca-Cola can that you look at. These are the double seam. So you need a support. In this case, the support is shown here is a plywood, or it can be a cement board, something rigid and continuous, not intermittent. And then we have a foam. That foam is introduced as a noise dampening foam. It's also an insulator. And in the case of a metal deck as a support layer, underliner, the foam also will separate the two metals. So this is an example of the U value, same 100 mm, but what you can see, I want to highlight is this, the construction of it. So you go do the same stuff, right? Okay, up to this point, the normal trapezoidal corrugated profile, you just install the roof on top, right? The clip lock type. But for this, can you actually install your standing seam over this finish layer? The answer is you can't. Very obvious. There is no rigid support. Okay? So here we introduce metal deck as the underliner. It can be a cement board, then your goods has to be closer, or the plywood. So here we use a metal deck. Then in the metal deck we have strips. That is to take care of the sliding clips that we use for installation. Then we put in the noise damping foam. Then we install the standing seam roof. So this is important because you need a rigid support for this kind of profile. Here is an example of what we do even with the ZAC 40 kg rock wool like previously without the support is incorrect. So the correct way is you can use that wool as in between, but then it must be incompressible. So here we use a hard rock, 175 kg per meter cube. Is incompressible. We use this for membrane roof as well. So this is expensive. We have used this for solutions in the KKIA airport to achieve the design intention as well. So this is a consequence of not having a rigid support in your system. How do I play the video? You see, there's no rigid support. What in this project, it's a 40 kg rock wool below with bubble fall and foam all together compact. So this is what you get, right? Because it's not rigid. So okay, so this is a serious outcome of not having a system done proper. This will be a permanent damage. So this is not oil canning. All right. Later I will share that they think it's oil canning, but it is not oil canning. Right. I have industry player who does this. This is a real life project. I will not quote. I got industry player in this room as well, and I hope we are all promoting the right system for the market, for the benefit of the industry and for the benefit of consumers as well. Okay, next, oil canning. So what is oil canning? It is some perceived visible waviness, right? It's waviness. Like just now is dented, is not waviness. So profiles commonly with broad flat areas, like I say, the architectural profile, are more likely to display this waviness compared to the corrugated. So the corrugated profile, like the clip lock tab, also has this oil canning. It's just that it's not so apparent, right? You have a lot of ribs, a lot of mini ribs. When you have a flat surface, it's very, very telling and it's very apparent. So then the degree of waviness is really tough to measure. They measure actually the wave height. So it's impacted by lighting or weather conditions. Hot day, sunlight, west side. After rain, cold weather, the waviness varies. It looks different. I've got a lot of feedback to say, hey, why is it so wavy on a hot day, afternoon? Then in the early morn, it was okay, acceptable. So this is not defects. These are just the inherent characteristics that I want to highlight. So this is oil canning. Okay? This is a wall. It can't be dented. So the key point that any manufacturer assures, if anyone assures you that I can give you an oil canning free architectural cladding, I think you better think twice. Right? You can't avoid. It's how much you can minimize only. You can never avoid. So oil canning, emphasize again, is a natural characteristics. So this is architectural profile, right? So it's flat sheet, just like flashing. When you do flashing, sometimes you want to cover something very wide, 400 mm over. And then later you complain, you see, wow, oil canning wavy. But you can do something to improve in the installation, but you can never avoid that. So when you customize the flashing, this again, especially visible flashings, you have to give some due consideration. So corrugated profile like this, they do have oil canning, trust me, but you do not complain because it's not apparent. So what causes oil canning? Thermal expansion. So if your system does not allow thermal expansion, then when it expands, it causes stress, induced stress, and then it will buckle, right? It's some kind of buckling that causes oil canning. So the standing seam has a sliding clips to allow for thermal expansion. If you install without the sliding clips, then you will have more serious effect of waviness. Then you don't know why. All right, okay. Then material thickness. Thin material tend to have more serious oil canning. So the thicker material is better. So again, the support. Everything has to do with the support. If your support is not in alignment, it's going in and out, it's pulling the material, definitely you have very serious oil canning. So what do we do to minimize? Generally, the thickness. The thicker, the better. But then again, you cannot say, I want a standing seam 1 mm thick in color bond steel. It cannot be done. It's too hard to fold. Because you've got to fold it very severely, it will crack. If you use non-ferrous like aluminum, titanium, zinc, yes, you still can manage. But that's about it. That's about it. The project calls for 1.2 mm thick. And it's out for tender. And that exercise went on and on and on and on. Dispute. We are supporting the main con to say you can't be done. So eventually came down to 1. Right? Came down to 1. Alameda Shopping Center is 1 mm aluminum. So it's pretty flat. But it's already against the norm. Standing seam is a European system. They have this, later I share, the kind of tools that you use to seam. It's not designed for that thickness. So I call it the industry norm thickness. So color, this is again very subjective. What we gathered from research is that the lighter color, this is about matte now. Of course, the matte finish would be the preferred choice. When you have very glossy surface, it amplifies your waviness. Then the color. Apparently, lighter color, I always, before this, have the belief that dark color will be a better choice, right? Dark matte. So apparently, dark color has got one inherent characteristic, absorb a lot of heat, right? Induce more expansion and movement. And also, dark color as a background seems to amplify the waviness. I just later on share some photos. But of course, you use textured surface or you emboss the surface, it sort of diffuse your reflection, then you can achieve a better finish. So this is Alameda. It's 1 mm thick aluminum. It's very nice, but it burned 3 of my seaming machines on the job because the machine in Europe is not designed to take the thickness. So it's by force, all right? By force. But like I said, this is a good example of minimal oil canning. These are foreign projects. If you look close enough, you can see the oil canning. Because once you seam, you move, you induce stress. The less you disturb it, the better you are. So for standing seam, we have a Winkle weld and double weld. So for Winkle weld is 1 fold, 90 degrees. Double is double. You fold it down again. So for cladding, if the wind is not severe, we go for single fold. Because the second fold is going to induce a lot of stress. That's where you get more serious oil canning. But we have a snap weld system that looks like standing seam that you actually click on without inducing stress, like the link. So again, this light color. Somehow, maybe different time of the day, it doesn't look so apparent. Okay, this is dark color. It does shows a little bit more apparent. It could be amplified by workmanship. I'm not sure. Okay. So the color do play, but go for matte. Go for matte. Unless it's like this, where the oil canning is superb, right? It gives you all the shine and shimmer. If you are Guggenheim, you're okay. So next, sharing some flashing details. So this is a typical ridge capping, all right? Everybody do a job with a ridge capping, somewhat like that. Like this project, because what I'm trying to emphasize is screw on. You screw the ridge capping onto the profile. But having said that, can that be, the screw be avoided? Can you have a concealed fixed ridge capping? Certainly you can. Certainly you can. Right? Like this. We do all our standing seam profile with concealed fix. Concealed fix, because that's where you get your quality, right? You pay a lot more to achieve a high-end finish. You imagine you screw up on the ridge. So similarly, this kind of concealed fixed ridge can also be done on the clip lock type. Can be done. The only thing is it has to be specified. Specified and cost in. Okay, I'm talking about reality. You don't go to your project and say, hey, I heard Sysmaster can be done, but why aren't you doing? Hey, who's paying? Who's paying, right? It's always the case. I always have this issue in between men to confront. Then your flashing size, why so small, cannot cover that? Your BQ says is only that big. Anything bigger, who's paying? VO. I'm just highlighting these are issues, real life issues. I've been on the roof on projects where I've been questioned. I look at it and stand and ask, why so small? Yeah, it should be bigger. Then the contractor says, the BQ says that is the good size. To extend that, who's paying? So developer also silent. So again, what you want has to be translated into documents so that the system design and cost is captured. Standing seam also screw fix ridge capping is been done, because you cannot reject. You didn't define. You didn't say it has to be concealed fix. So typical gable end, if you are talking about a clip lock type, that's a screw fix, right? So the gable end, you see that kind of cornice design. Normally we will recommend if your fascia is very wide. They say it's 400 or whatever. So why we step it is to reduce your flat surface to minimize your oil canning. So that's one way of addressing to minimize oil canning. But if it's a standing seam system, it's very neat. It's very neat, okay? Like this. This is slides I want to share. Wall flashing. So it's a common practice in the market that you have a cut groove with silicone sealant. Today, cut groove is just a groove line. In the very early days, JKR cut groove means they actually, during plastering, they actually create a groove during plaster. But today, construction has moved on, maybe with technology. Today is just a diamond cut groove. Then you seal up with silicone. Common detail and commonly done. This kind of detail will fail very badly if your plaster brick wall quality is very, very poor. Why? The flashings comes in the length of 2.4 meter or 3 meter. It's as straight as a ruler. But your wall is going in and out. So your cut groove is about 20 mm only. So if your depression on your wall is more than 20, it doesn't bite. It doesn't bite. So the job is completed and then it leaks. So again, to me, it works, but it has to work well with a good workmanship. Otherwise, we recommend a better solution, double flashing. Okay, you can have your first flashing without cut groove. You just tuck in, open the joint and put up some silicone there. That is your secondary defense. Then on top, you have another flashing to cover this. And here you can cut groove, you can have same detail, you have a double protection. Okay, one more point why this is more foolproof. Because this one on its own is attached to the roof. When the roof expands, thermal expansion, especially very long length, what happens? It pulls the flashing. So your silicon get weakened. So it's going to be like, oh, maybe a hot day you got more problem, right? Due to the expansion. So this, again, good to have, but please cost in and budget and draw in the QS captured. Everything will be okay. So another thing from observation from the industry practice, true or false? Flashing must always be GI. And flashing must be specified in gauge for thickness. And flashing must always be thicker. This is what I have extracted over the years of my experience. I've been in this industry 37 years, right from the very beginning to now. This doesn't change from 37 years ago till now. So the only reason is cut and paste. Okay. So, is it true? Some of you might be just thinking, if you are doing a project, find time to look at your BQ. I know the QS is taking care, but QS cut and paste, and it's not what you like. So this is a BQ, quite typical. 22 gauge galvanized iron as described. Here they even put soldered joints, right? Nobody does soldering anymore. Almost extinct. You do for gutter those days. I don't think you can get anybody to do soldering now. The tinsmith soldering shop also closed already. Okay? So this is your tended BQ. Can you imagine? And it's true. It's a real BQ. So it's GEI gauge 22. Anyone can tell me how thick is gauge 22? How thick? Is gauge 22 thicker or gauge 24 thicker? Anyone take 24 as thicker? No? 22 is thicker. Smaller the number, the thicker. It's more for the wire gauge, all right? So gauge 22, the project guy who wants to do an honest QA/QC also don't know what thickness to check. Right? There is no meter to say gauge 22. It's only mm. So gauge 22 is supposed to be 0.7. But again, the word gauge is like thickness. You don't define. You got SWG gauge, you got American gauge, British gauge, at least 7 to 10 variation. And they all come out with different thicknesses, 0.7, 0.6, 0.65, again. So you are not specific. Next thing is a GI. That one, I will come to that later. So when you have a zinc-lum roof and you put that in your flashing for tender, and your end result could be like this, right? The GI did not perform in terms of durability in tandem with the zinc-lum material. Another one, sharing. This is all actual BQ. Here is gauge 22. Down there, because it's a color roof, so they have a painting over the GI. Very professionally done. Jotun paint. Must be a very good paint. They specified Jotun. How many layers of coating, blah, blah, blah. So what you are telling the contractor is, you buy a GI sheets, you fabricate, then you paint according to these specs. Right? That's what you do. That's what you say. So what do you get? Very likely this. The paint has got no adherence. Few painting got no proper control on your surface. How the color bond is coated in the factory, they got cleaning of your surface to get rid of your oil and dirt before you paint. This one, few painting. No adherence. Terrace house, you look at it, it's mostly like that those days. It can be overcome with the right specification. Will you send your car to overpainting if they don't have an oven? You don't. You need to oven bake. That's the key. So this one is even more interesting. You got two different thicknesses, galvanized. Gauge 10 on top, gauge 20. I also haven't got a clue how thick is gauge 10. It must be very, very thick. Maybe 2 mm. Then gauge 20. Gauge 20 is supposed to be 0.8. The standard is 22, 20, 26. Last time metal roof used to be sold on gauge number. 0.42 BST that you commonly use is called gauge 26. Anyone still looking at gauge number for your thickness? That's how it is. So here you got two different, the thickness are not well defined, and you got two different thickness. Again, even if you specify it correctly, my advice for practical reason is for one project, unless your roof is 0.48 BST, your cladding is 0.42, for example, then you got different thickness. Otherwise, to be practical, we receive inquiries for projects where there are different thicknesses coming for different applications. There's not enough quantity to order the calls. You know what I mean? You're talking about reality business. I'm not going to order 6 tons to supply you 500 kg. Right? All the industry player will not do it unless you have ready stock. Okay, this is something practical to take note. Incompatible. See, this is our product being specified, very grateful. The architect, we see the architect, everything done, system developed, blah, blah. Swiss mile, double weld, standing seam. Right? Then the BQ came up. What happened? Again, the galvanized iron. You see? Right? And the best part is this galvanized iron is not gauge number. They have improved 1 mm thick. 1 mm thick. And then the exposed surface with spray painting some more. They don't even tell you what paint, Jotun paint, how many coat, just spray paint. So that is what your specs is. And they put stainless steel screws. Stainless steel screws is not compatible with carbon material. I'll share that later. So all this is in the tender. And when people come to us to quote, I'm really lost. Right? Contractor also don't know what to feel. But you can laugh at it, but this is real. Right? This is real. So that's why I say, as an architect, do pay some attention to the BQ. So I was saying galvanize, the word galvanize. Galvanize is just like zinculum. Right? The metallic coating is not specified. They go for hot dip galvanized also, how many microns, right? So this galvanized, you can see that galvanized Z12, 120 gram, 180, 220. If it's only 120 gram, this is what you get off the rack if you don't specify. 500 hours soft spray already condemned. Your residential house, party wall, very likely made of this and just painted over, brush paint. So you can avoid that miserable party wall which I hit when I was staying in the terrace house. It's so badly corroded. Okay, so again, like I say, even you want galvanized, I'm not saying you can't. Please specify what's the coating mass, metallic coating. You don't specify, you'll get the cheapest. Contractor's mentality. So there's nothing wrong to specify the flashing using the same material thickness as the roof. You got uniformity, you got similar performance in durability, then move on, bingo. That is my recommendation. This is again ridge capping, same thickness. So specify material of the same thickness as a roof. Try not to use thicker because you might have problem managing your project. Supply issue, and specify thickness and the girth, because you don't specify girth, the 600 coverage, you get a 450, you got a 300, then you get that short coverage on your roof. So this is by way of specifying that you avoid those kind of horrible outcome. Okay, right tools. For standing seam, you need to have right tools. These are seaming tools. One for the right angle, first fold, second fold. Like I said, there is a seaming machine. For Alameda, it has burned 3 of my machines from Europe because 1 mm is too thick. The design for that is only 0.7. That again is a soft aluminum, not even steel. So you have all these dedicated tools. I'm not sure whether you have seen. Like I said, standing seam is a European system. It's not Australian. These are tools from Europe. They are all for a purpose. The hand shear, the curve, is like unlike the normal shear where you cut and then you get stuck, just like your scissors cutting a paper. This can cut from one end to the other end without any interruption. So you need mallet. So this fixing method, you have a seaming. I will not play the video. So at the end there, the eave, you need to knock it down using a rubber mallet. So you don't have a rubber, you use a hammer, that's it. So what happened is, you have the right tools, you can do a good job. Like this, the eave, you got to skive, you got to knock. If you don't, you have the right tools or the skill, you get this. This is also from a real life project. Okay. It's taken by a roofer given to me. He said, hey, Mr. Lau, why you lost the project? They are doing this quality. I'm not saying the company is no good. They don't have the right skill and the tools. That's what happened. Then the trimming on site. Very often, this is not controller. You leave it to them. The fastest way to cut a material is using the first one, the cross, the fly cutter. Shh, very fast. Rather than using a nibbler. On the bottom side, you have a nibbler. But I hardly see anybody invest in this. It's just go a jig, 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 jig. Hand shear, very slow. And like I said, you can't cut through too deep. So what you get is, when you use the hand shear, and that one, the cut edge still has the governing protection from your coating mass, whether it's zinc or zinc-aluminum. Use that, you cut the surface, you burn it, you damage it, no more protection. You start to rust, just like this. Right? These are due to wrong tools. They actually use oxy-cut even sometimes. All these will burn the edge, and you will have permanent rust. Shop drawings. Okay, this is a clip lock tab. So on your eave, you have no choice. Right? It's better straight down or do whatever. But if you do a standing seam, that's your neat choice. Right? If there's a fascia board, you can do this for the clip lock tab. If no fascia board, again, whether it's a straight line down, if your surface is 400, 300 plus, this could be oil canning issue. Now, this is a gable end. This is the interesting one. Gable end, see the standing seam is so neat. Standing seam tile roof on the mono-pitch design, all sides are the same. Very neat. Not in the clip lock tab or the trapezoidal profile. So on the top, this is a clip lock tab. Your capping has to cover the corrugation, right? You have to cover. This is for the trapezoidal or clip lock tab. But for standing seam, no. It's the same treatment. It can be done as a eave, as a site. All the same. So that's why standing seam is an architectural profile. This project, okay, look at the skylights. When I first saw this, I was like, oh my God. Skylight spells trouble. All right, so many. So one way of addressing those skylight is that skylight is raised skylight, fortunately. Is raised up. So these are the two sides of the skylight. And that is a standing seam roof. If it's a trapezoidal clip lock tab, no way. I used to answer no way. Because developer also said standing seam is very expensive. Why not clip lock tab? Why not clip lock tab? I said it just can't work in your project. It just can't work. Right? Even in standing seam is already a challenge. Standing seam can be folded, can be manipulated to meet your requirement, but not the trapezoidal. So this is the lower end of the skylight. Upper end. This is the most difficult part because you're interrupting the flow. Where is the water flowing? Right? So when you have a continuous long skylight raised up, you need to have a gutter already. There's no other way. So these are example of lowers opening. Whether you have a hood. This is what you call window at the sides. This is a Now it's quite common to have warehouses, factory to have double skin. That means the wall has got 2 layers and insulated. Even not insulated, like the hanger, they have 2 layers. They want to cover the wall goods. Inside looks very nice. No exposed sea channels. So skylights for factories, typical. Those days, easy. Today, because of the U value, remember, so thick, right? So thick. So you cannot just fix the skylight like before. So you need to have a system. The skylight has to sit on the subgird as well. Otherwise, it's floating there, and you got to do a capping on the side to seal up. So you need to provide detail. Without detail, then you leave it to the hand of the contractors. Okay, coming to the last sharing, do's and don'ts. This one, I'm not sure whether you all know about this. Lining arrestor. Copper is incompatible. The potential difference between the metal and copper is so high. It's just like a battery, when you're together, you've got water and oxygen. It corrodes what's below. So you can use aluminum, or you conceal your copper tape. Screws, this is the least concern, or not least concern, least attended to. Right, nobody specifies screws. Just put up all your project, everything proper, but you didn't specify your screw. Right, there is a screw specification. You use class 3 or class 4 for corrosive environment. So then stainless steel screw. This is actual project research by BlueScope. The stainless steel screw somehow corrode the zinc-lum. See the black eye? We always think stainless steel is the best. I can afford, I want the best. But the best is not compatible somewhat. That's my message. Okay? So if you don't specify the screw, the normal screw you buy from hardware, buy from anywhere, you get this. Warranty, 30 years, 25 years, the screw, 3 years, rusty, koyak. Right? So pay attention to that. And with that, I end my presentation for the morning. Thank you.
Good morning, everyone. Thank you so much for coming. I know most of you are here because you need 20 CPD points for next year. And this one has 4 points, yeah. Please allow me I'll try and close everything off in about 40 minutes. I'm going to just share a bit of my experience with steel and a bit of what I learned in my uni days and how it has influenced the way I practice as well. The last part of my talk, I had the privilege to become a jury member for the BlueScope ASEAN Awards, and I'll share with you a few of the winning. There were 5 winning schemes, and I'll share with you why the jury selected them. And I hope that this will encourage you all to be a bit more adventurous and look at steel in a different way. Okay. I studied in Australia. BlueScope, by the way, is is known as the big Australian, Broken Hill Proprietary (BHP). When I was studying in Australia, I started in '83 in a very small university in a small town called Geelong, and this book came out in 1985. I was in second year, I think, second or third year. And this book greatly influenced the way I think and the architecture that I do. Till today, I feel that this is like the Bible of sheet metal building, okay? That means metal sheet. Corrugated iron, while America has a history of it as well, but to me, the Australians really perfected it. And BHP and BlueScope, as it's known today, were the pioneers of it. Glenn Murcutt won a Pritzker Prize. And this house, in those days, it wasn't called Mary Short House. I think we knew it as the Kempsey farmhouse. Those of you who are old enough to remember this. A very simple building, but it changed the whole way architecture was done in Australia. And one of the things I really loved about this house was there's no ridge, and they could bend the metal. And those days we used to use custom blue op. those of y'all who practiced in Australia before. And getting rid of that screwing on, the messy detail of the ridge, having the metal being able to, the corrugated metal being able to curve over the form, took away from the traditional pitch roof and created a new form. It looked almost like a leaf. Those days, he likened it to the gum tree leaf that fell on the ground. That steel was malleable. It could actually handle a curve. And the way the building is lifted off the ground, and the whole concept that came from Aboriginal thinking about lightly touching the ground. And at the same time, it dealt with termites, it dealt with cross-ventilation. Interestingly, a simple little house like that became one of the most influential buildings in Australian history. So when we look at this, we are reminded a bit about our kampong houses. Okay, except that the detailing here is really simplified to Mesian standards. And to me, when I saw this, it greatly influenced the way I think of slimming things down and paring things down to convert craft, a typical farmhouse craft, into a piece of art. And I think that's what we have always been endeavoring to do in architecture. Another thing that in researching to do this talk today, I actually dug up his old drawings. This most significant building in Australian history was constructed from one drawing. And I look at my office today, to do one guardhouse, there are like 2 sheets, to do submission and all sorts of things. I don't know why we got so many drawings. One hand-drawn drawing with every detail in it specified, built this house. And when you look at it, it's a incredibly efficient form of drawing. I'll take you through a short history of steel. Steel is not new. In 1779, you find the first steel structure, and this one is known as the Iron Bridge. And I put in a picture there how it was constructed. So it was looking, before that, steel, they couldn't span across great spans of river or ravines. And when steel was invented, it could actually give them the opportunity to do long spans. So one of the things about steel is that it's strong in tension, okay? And it can take you to greater lengths. This in 1851, the next great building that used steel, and a significant one, was the Crystal Palace by Joseph Paxton. Those of you who study architecture, in your history of architecture, you have seen this building. It was the introduction of glass. And glass, it was built almost like a Gothic cathedral, except that instead of stone, it was replaced by steel. And instead of infills of stone and brick, it was replaced with glass. And it became a very significant building. This was during it's like the expo that was held in London. Today, in our expos have sort of lost its meaning, in the sense that there's not much innovation, there's not much stretching the envelope, but rather you find in the pavilions we sell bird's nests and durian cake and all those things. Whilst the original intention of expositions was to use it as an experiment to show how great our technology and innovation is. The first high-rise building using steel was the Home Insurance Company, followed later by Sullivan's high-rises, okay? So this was a steel frame building, 1885. And then in 1889, Eiffel Tower, again, this was in an exposition. This was in the Expo of Paris of 1889, and they built this structure that still stands today. Then came the Art Deco, Art Nouveau movement, and you find steel being molded into the merging of craft and technology and art coming out into the metropolitan train stations. But I think the modernist architect, the famous ones are Walter Gropius, Mies van der Rohe, Loke, and of course Frank Lloyd Wright. Frank Lloyd Wright was a very nature-based prairie houses and repetition and using stone and pitch roofs. Cobb is to me, and I've got an exhibition on in the Toffee. Cobb is the Picasso of the art world, a person who evolved over time and could change and keep innovating in one lifetime. But the one who really took steel to the great extent, and one of my favorite architects, and I actually studied him in my 4th year. I spent the whole of 4th year researching all his projects and his detailing. This is the Barcelona Pavilion. It's been rebuilt in Barcelona today. If you go to Barcelona, don't just go and look at Gaudi's work. Please go and look at this building. It's pretty incredible. And the cruciform column, those days they didn't have all this. It was actually an assembled column. And you find, if you go and see Alila Uluwatu by Woha in Bali, there's a lot of the impressions of this over there. Then he did the Farnsworth House, and I put in the pictures of its construction. Till today, sad to say, we've been practicing 30 over years, I've never been able to build a roof as thin as this. Okay, and to me, I mean, try as I might, because I don't know whether it's the tropical thing or I still haven't moved my craft into art. My gutters are too big. I'm always afraid of the rain. And therefore, after a while, you see the top part becomes thicker and thicker. And the moment the proportion is gone, it doesn't look like this. Okay? And again, you find the house is lifted off the ground. And even the steps are like floating. Okay? And this is known as the Farnsworth House. And it's a steel construction. And the first real piece of art without any decoration. Before that, you find all the steel framing going up for high-rise buildings, but they still put a lot of stone on it and decoration and moldings. So when you look at it, it still looks like a wedding cake. And Mies, when he did the Seagram building, he took it to the ultimate. It is a modernist, clean structure, and I really love this building. Those of you who have been there, you can, it's almost still exactly the same as it was before. And his detailing of how you do curtain walling, etc. Then in 1977, the high-tech movement came, and this is Pompidou Center, which is still there, and if you get a chance to go and look at it, you should. And after that came the Lloyd's Building by Richard Rogers, 1986. And in 2003, with the beginning of computers, parametric design. I think most of us do parametric design now in our offices. And your new graduates, when they come, don't hold them back, because we always say all these things cannot be built, but there are living examples of them being built. And the kids today, when they play a computer game, they can see so many things that are happening, and they can still shoot the guy that's the bad guy. When we look at it, we can't even tell who's the bad guy. And we can't find our way around, because some of us are from the old generation. Bloomberg was the first one to come up with a new screen that had a rolling bar at the side. And even that we found quite confusing, when it first came out. Then CNN came out with the rolling bar at the bottom. And today, when you don't listen to the news anymore, you just look at the rolling bar and you got all the headlines. So we start to become more perceptive. Our eyes can see, but whether our brain can actually program it and translate it to reality. Those of you who have been to Los Angeles, please go and have a look at the Walt Disney Center. An amazing piece of sculpture. And as Roncham, as Le Corbusier's ultimate last building, that to me, his greatest building, Roncham Chapel, this is also like a Roncham Chapel, just as much as in the Bilbao Guggenheim. When you go into the building, you see light penetrating and giving you goosebumps when you see, it's as though God is in that building. So Gary, in a sense, he must have hired some. If you look at Frank Gehry's body of work, and I have his book on that, his earlier work is, I think some of my work better than his earlier work. They were very normal work. He did schools, he did army work. They were all rectangular square boxes. Then he did his house, which was a bit of deconstructivism. And suddenly, he could translate into free form. I went to his exhibition in Paris, where he did the new museum. And the first exhibition they showed was of Frank Gehry designing that building. And there was a video, and in the video, I saw a lot of Malaysians in the video, model makers. So he starts from a model this size, then he does a model this size, and he does a bigger model. So all of them were shown there. And I saw that they translated it all from parametric design. He found the tool and used it first. Therefore, he broke a new boundary. Then Herzog de Meuron took it one step further. It was not only folded planes. It wasn't a facade. The whole structure became the architecture by itself. So these are some of the progression of work. Okay. Now I take you back to some of my boring work. I've tried to transition my work more and more towards steel, because if you understand architecture, the innovation always deals with the technology of the age. So when I speak to some people in universities and they say, AI is, we should ban AI because there's a copyright issue, it's not the students' work. But at the same time, technology has moved on. And as we are architects and innovators, we must embrace that technology and use it. So I've been increasingly using steel in my work. And if you look at this simple renovation, I'm not going to talk about the design, I'm just going to flip through very fast because it's nothing compared to Guggenheim and all this. But I could only have done that long span with a steel because it is light, it is, and it looks very modern. And I merge it with brickwork and glass. So in a way, I'm transitioning from just traditional buildings. I'm starting to incorporate steel into my work. And balconies can cantilever out. You know, balconies are never used in Malaysia because they are very dusty when they are tiled. So when you walk up there, you walk back into your room, your feet is very dirty. So most people don't like that. So what I've started to do, and I learned this from Siksan when he did his circumping, you put a metal grating floor. And you walk up there and you walk back in, you don't feel like your feet has picked up a lot of dust. And when the rain comes, especially when the grating has groove lines, it is actually self-cleaning. So the dirt collects in the little groove, but when the rain comes, it falls into a groove and washes it clean. So increasingly, I'm using a lot of metal grating in all the external areas because it also solves my other problem, which is the downpipe. Yeah. I think for mass housing or condominiums, it's still quite impossible because you can look up and I think it's called upskirt, right? So that's this house, and looking at the big long span across the whole house. I just want to show another house where that was just a renovation. And this one, the land went down, and what I wanted to do was the original house, I tried to save the house, but it was impossible to redo because it had small little rooms, and it had a staircase right in the middle, and I couldn't revamp the house. So I actually demolished it and built a new house. So what I did was this time I built a structure up, almost like a water tank in concrete, and I suspended the rest of it. I used that concrete structure because steel is very strong in tension. If you don't believe it, you take a steel bar, you try to, you can bend it, but you can never pull it until it becomes so thin and breaks. So what I did with this house, I built the concrete structure, almost like a water tank, as it was rectangular, and I hung all the spaces below. Another thing that I've used quite often in most of my custom-built houses today is I hang the staircase from the roof down. And I find that it's much better for me because the old staircases are concrete, and you need 2 or 3 tradespeople to finish it off. You need to cast the concrete, and it's never casted correctly. You got to hack it, repair it. Then after that, the handrail guy comes in, and then the floor finish guy comes in, and then you got to do the sides. And everyone who comes in destroys the work of the earlier one. And they just go back and forth, and the staircase becomes the most difficult part to finish properly. So what I do today is I hang all my staircases using steel, hang it from the concrete structure above, which is usually got a 25% safety margin. And I use a singular material, which is steel, and the staircases are there. This one, I did another one, which is a partition that divides the space. And again, the whole shelf, this guy collects old terracotta, expensive terracotta. Okay, so he was a bit worried because there were no legs except the wires that hold it to the ground. And I hung the whole shelf from the top down. So that's the building, and that's the staircase that doesn't touch the ground. It's just suspended from the top. And if you look at the picture on the right, over the front doorway is a concrete coping that protects the front door. And again, this whole concrete coping is held up by a steel pole from the top. So everything looks like it's lifted off the ground. So these are some of the things that I'm experimenting, because I'm trying to work with the nature of steel. That steel is very strong in tension. I'm not showing a building that I did, but I think some of you have already seen my talk on that, which is PJ Kita, where it's a mushroom structure, and all the upper floors are all suspended from the top floor. So that's the house, Kamari's house. And I had a chance to I was selected to do my church, and this glad tidings in section 13, and the land goes down, but going down gives you opportunity to tuck all the services underneath, but the church, I was influenced by the John Utzon's opera house that you actually walk up. So I just came out with this sketch, and then we did that design. And again, I tried to look at parametric design, even though that time I didn't have parametric design. I actually built a model, and I think Susma, you built the roof for me, right? I don't know how he built it, but we got it done. Okay, it's asymmetrical. It's not a symmetrical sort of thing. Okay, and I think it's standing seam, right? Yeah, still standing. It's got 3 auditoriums inside, so it's actually quite a large building. Okay, so and they wanted an external chapel, so we again use steel and try and make it as thin as possible so that it looks like as though it's floating off the ground. I think you've seen these slides. This is a Setia Convention Center where we used standing seam and did almost like a spaceship landing there. This piece of land in Setia City is fronting the lake. It's actually a temporary building. The land is actually zoned for condominiums. So after a while, we will dismantle the whole building and we can move it to another township. And it was built very efficiently. I think the client made back all their money in about 5-6 years, okay, because of the conventions that they held. So the other thing about steel is that it's recyclable. And if you design it in modular form, all of it can be dismantled and reused. They recovered their money so fast that they commissioned us to do the next one, which is an open flat floor, 5,000 seater, and this is one of the biggest in that region. And this time, I was looking at Google Earth. When you want to find a place, everyone looks at Google Map. And I started to realize that the roof of a building becomes a signal. It becomes, hi, I'm here. So whenever I ask people to Google the place, they Google it and they find these funny colors. I said, that's the building. And I even went further doing one for Cyberjaya, but unfortunately the project has stalled, where I put a QR code using metal. I do a QR code on top of the roof, and that one is almost a pure rectangle. So the QR code can be using different color metal, or it can be actually even solar panels. And then you screenshot it, you can make it into a QR code where you can search that building, you can scan the QR code, and you can attend a lecture or a talk there, and it takes you straight into the convention center. So the roof now to me has a lot of opportunity, and we shouldn't just be stuck with a black roof or a brown roof or something like that. So these are some of the things that we have tried to innovate with. This is a project we recently finished, and we won a PAM award last year. I started my office in Subanjaya. If you see the round circle, 1994. When we first started my practice, I left BEP and joined another friend of mine from Deakin Uni. We had no work. For the first year, 4:30, we were already very free. So we used to go fishing. And we spent all our afternoons, 4:30, we went to the lake. And that's exactly the same spot where we would fish. And my wife would finish work about 6, and then she would come and join us, and we would go for dinner. The time was my girlfriend. Those were good old days before we got married. Then we got asked by Sam Darby, the client, to help rejuvenate this building. And it's like 30 years later, and coming back to sort of my childhood or my young days there. And the buildings have been very dilapidated. And I'm just trying to show that sometimes you don't have to tear everything down, and steel has that potential to be rejuvenated as long as the structure is intact. So that's the condition that it was in. If you see the picture on the small little building there, the client wanted to tear everything down and remove it, but I actually said that we can actually save as much as we could. Yeah. So that's the completed building. It's actually a real photo. A lot of people think that it's a 3D animation, but we wanted a simple white building in a green environment. We totally refurbished the existing building, and I think we only spent something like 2 million on it. Yeah. I kept that little shed, and I told them don't demolish the little shed, because that to me had the only domestic scale in this very white building. And today there's a cafe there, and it's the most popular place in the whole location. We did all the walls have a counterweight. So you just have to lightly pull the chain, and all the walls will open up to give you this full view of the lake. That's with all the windows open. Yeah. Okay, I just end with I had the privilege last month, I think, or 2 months back, to be on the jury of the ASEAN Blue Scope Steel Architecture Awards. I think it's good for architects to take part in these things, and I'm very glad to say that out of the 5 prizes, 3 were won by Malaysians. And the rest of the jury, Ase is the president of the Thai Institute of Architects. Dr. Trong is from the university in Ho Chi Minh City. Richard Colson is director and managing director of Cox Architects, Philip Cox. And Ahmad Dani Tardiana, a very respected architect from Indonesia. So I had the privilege to be on the jury with them. And I'll just show you the winning awards, the winning entries. You know, the good thing about every now and then I don't take part in competitions. I try to be on the jury because I like to see what the competitors are submitting. Okay, so when I saw some of this work, I said, oh my God, it's going to be harder and harder to win. This is by Melvin Kenny. It's incredible when he showed us and presented it. I couldn't believe this was in Malaysia. And an amazing steel structure, kept all the trees around it. He only cut 2 trees because it was in the way. and using steel to wrap all around, as pots. And that's the detail of it. And they're exactly nice villa rooms, 1 top and 1 bottom. And that's the construction that he showed us. I'm showing all the slides from them. They have given permission for me to show it. But I wanted to share with us some of the possibilities of steel. I think those of us who study in Australia, we are well versed with pole houses. And on Sydney, North Shore, where it's very slopey down to the waterfront, a lot of those houses are so-called pole houses. And when I saw this submission and the presentation, I felt that this is a pretty good pole house, yeah, except that it's in steel. And those are the completed. It almost looks like, you know, if you collect honey from the orang asli, it looks like the tualang bee hives, you know, on top of the tualang tree. And I thought this is so biophilic. And when I saw it was from Malaysia, I told my office, I think we need to up our ante. We need to improve our design because we've got people that are already doing this sort of things. Okay, so I just want to, not to make you jealous, but to make you think out of the box. And I met the installer. Unfortunately, it's not Swissma. I think Swissma's competitor. But likewise, Swissma can actually help you with a lot of the detailing. And it cannot be no longer without the specialist being involved. So I think sometimes we just give to Mr. Lau a very unusual form and tell him to solve it. The other winner for institutional buildings is Masjid Dain Abdul Rahman. This from Razin. And again, it's a totally using steel as a framing and using it to create a permeable skin, a second skin. So when you're inside and you're looking out, you get this filtered light, and then you got trees in the veranda space, and you don't know, you feel like you're actually worshipping in a forest. Okay, and the merger of raw materials, nature, and using steel framing as a skin. It's the metal is actually only one shape, but he randomized it in such a way that if you look at the leaves, it is as though nature controlled it rather than following a formula. And beautiful moss. Yeah. And another winner was from Sarawak. Interestingly, it's the CIDB Convention Center. So even the Sarawakians are really, catching up with us or scaring us with their design. It's by Archiscape, Kwek, Desmond. Yeah. And that was the final shape of it. And very nice, pure form. And that's the building. I think the jury was very impressed when they told us that before they started construction, there was a crocodile in that lake. And they had to move the crocodile away. Otherwise, you couldn't get the building built. I must use that story for my next awards. And this is a Thai winner. Very simple building. And they beat some other very grand houses from Indonesia and elsewhere because of its simplicity. And those were the drawings that were sent. And this is the entrance. I'll just run through very quickly. It was in a squatter sort of, to us it's squatter, but to them it's house. And it's blending into the community. It's totally cross-ventilated. It's lifted off the ground. It's got all the criteria that I felt the Farnsworth house had. So I earlier showed you some of the slides, and the jury, it was a very interesting intellectual jury. Okay, there was no people from the industry. So we actually had good discussions, and we talked about what it reminded us of. And I said, this building reminds me a lot of the Farnsworth house. The platform, or Serambi as we know it, lifted off the ground, and then walking one more step or two steps into the house. And even the bed is lifted off so that it's cool, the slab is cool. Very minimalist columns, and very simple roof that was later lined with plywood. Very simple building. But you look at this image and it reminds you of the Barcelona pavilion, of sliding walls that not fully enclosing a space, where space sort of flows one into the other. The top is ventilated, the bottom is ventilated, as opposed to all the shanty buildings next to it, which are traditional craft, where everything sits on the ground. Suddenly you get this same looking thing that fits into the environment, but it is like a piece of craft art. It's a piece of art that landed there. See, so to us, it reminded me a lot of Miesian details. Okay? Very simple details, nothing extravagant. And this, of course, reminded me of the Kempsey farmhouse. Just a very simple corrugated iron. Mr. Lau, we don't use this anymore. Now you sell us all those expensive standing seam. Anyway, I'm just showing some of the potential of steel, okay? And this one was another surprise winner from Thailand. This is Thailand's Navy architects, and both of them that came to receive the award were ladies. One was a colonel. They got quite pretty army people. and an incredible building. And I don't know why our factory buildings don't innovate like this. Okay? So when we saw this building, you look at the front elevation with the two vents at the front, and the site is so simple but so efficient. And I'll try and explain it. You can go into Google and find it, I guess. It's a typical rectangular box, but there's so much. I think in the army, there's not many projects to work on. They probably spend a lot of time on it, right? Whereas to us, we just draw a square rectangle, pass it to a draftsman, ask Mr. Lau to give us the cladding detail. But there's a lot going into this building. And the first thing I told the jury was, it reminded me of the AEG turbine factory. And this was a groundbreaking building before the Bauhaus movement. Those of you who study architecture, by Peter Behrens. And it replaced, this was the beginning of glass, full height glass, 4 times volume, and creating almost like a cathedral for the Industrial Revolution. And to today, it stands there as an incredible marvel. And this is their building. You look at that, it's got the 2 little holes. So when I asked them after they received the award, have they seen this building? Have they seen this AEG turbine factory? They said no, they never heard of it before. And I thought, oh, we thought the inspiration actually came from there. Look at the side walls. Singular material, steel and steel cladding. And they are able to create, when the wind blows, it's not flat. It actually gets captured into the building. And you can see from the plan at the top, they just skewed all the walls, and the wind actually comes through. This is a foundry factory. That means there's a lot of steel, there's a lot of heat in the building. And they staggered all the walls, and the top panel is lifted up, and daylight can come in as louvers. So that's the inside view, and you can see from the dotted red lines how they use it as though it's inside and outside, the air just penetrates through, and it's just a simple factory building. And at the top there, they even have this, in case it rains or anything, they can still vent the building. And beside the red one, you can see they alternate it between a solid and a louver. So you get diffuse light coming in. And just by doing these undulations, when the breeze comes, it creates low and high pressure points that generate suction out of the building. And we just thought it's a marvelous piece of singular material, nothing elaborate, no expensive, innovative things, but just using a simple, singular material. Beautiful building. And it works. After we did the jury work on this, we talked about the jury, and they said that, we have designed so many warehouses, and not a single one of them has this kind of elaborate detailing. And we thought, oh, when you judge a competition, it really gives you a lot of information. Yeah. So I just want to end. I haven't taken too long. Thailand is very advanced in steel design. I think you can buy these books. I think Bashir can order for you. It's by Lee Zen printing company that is owned by A49, the biggest architectural firm in Bangkok. The A49 is similar to our GDP, except that they do a lot more things. They started this Lee Zen the same time when I was PAM president in 2005. We wanted to publish a book on Asian architecture. And after I finished my presidency, the next people who took over did not follow up, while the Thais did all their research and their section of the book was done. Then they asked us, where's the rest? Where's Singapore, Indonesia, Malaysia? And the new people who came in take over our place, they didn't do anything on it. So then Nitis, who's the son of the founder of A49, said, now mind, we're going to do our own. And that's how Lee Zen was born. And this, they have published, I think now they got 10 books on steel architecture. I have all of them, and whenever I go to Bangkok, or if I can get a copy, I'll buy it. The incredible innovation they have of using steel. And if you can get hold of these books, you look at it and you'll not be surprised why they have moved so far ahead, because there are people who actually publish the works. Okay. So I end with this. Glenn Murcutt bought the house after many years, and it's now his second home. And to me, even looking at the detail of the flue, on top there was a bird, it's like a magpie, and that one swings with the wind. So I always see this building, and I constantly marvel at it, lifted off the ground, not dissimilar to our houses in Terengganu, our old houses, meticulously crafted, and a person who understands corrugated steel sheet, of getting rid of the ridge and just bending the steel over. And I thought, till today, is rated as one of the best houses in Australia. And how a book influenced me. So to me, BHP, BlueScope, they originated from Australia. And Glenn Murcutt is the person that sort of derived the language out of it. Yeah. So thank you very much.
Okay, thank you very much, Tan. Wow. Everybody was really quiet and really listening. So nice. All right, so we will now open the floor for question and answer. If you have any question, please raise your hand. But in the meantime, I would like to invite both of the speakers to the stage. Please don't be so shy. There's a mic in the middle. Okay. Anyone want to start? Every time in the classroom, I always be the first one who asks question, and there will be continue on this question. But my question is a very, very basics and simples. We have a lot of design when we do our project in steels, but how we want to test that our design is okay, it can be done. Is there any method that you would advise us on, for especially designers? Yes.
Hello. Yeah, I think that question could be well posed to Dr. Tan, but anyway, coming from roofing industry, my perspective is you can be very creative in whatever you do. And Dr. Tan has already shown what the other countries are doing, how far they progress. In Malaysia, we are not short of expertise. A lot of you, some of you could be constrained by the concern of lack of expertise. But today I can tell you safely, whatever you see abroad, there's a solution in Malaysia. So all you need is, if it doesn't work out, you just have to tweak where you could, and let your creativity flows. There is solution in Malaysia.
All right, thank you. How about Mr. Tan? Yes.
Maybe, I think, we have put man on the moon. Unfortunately, we have forgotten how we did it. Some say that we actually never did it, right? But today, technology has changed tremendously, and the future one is actually computer printed, And I think anything is possible today. Looking at the work that, when we are judging the competition, one thing we noticed was there's not much innovation in the area of industrial buildings. And most of those that were submitted from Malaysia were very standard rectangular boxes with no cross ventilation, with no thought about, I mean, a warehouse, most warehouses, factories are not air conditioned. They are working spaces. So cross ventilation is something very basic. So maybe we need to look at how we can innovate industrial buildings, which are basically totally steel. So I think anything can be done. If cannot be done, you contact Mr. Lau.
Thank you for that.
All right, any question from the floor? Anyone from upstairs? Anyone? No? Okay, my next question. I think this is typical for any architects firms. We always have this issue with cost. How we want to manage that with steel when we have the client insist of doing that, and then we have cost in another picture. So how you want to manage that, Mr. Lau?
Yeah, I think question was posed by Mr. Tan. He said we are promoting this high-end standing seam for better business. No doubt that is actually correct. The thing is, why standing seam? The fact is, it gives you the liberty to express your design. If you use a conventional, you are constrained because it has no flexibility. Then again, regarding cost, I think it's the same. You walk into a BMW sales room, you want to buy a BMW. You can drive from point A to B with a product. Why BMW? There is a value to it. As long as the paymasters know what the value they are gaining, I think they are willing to part. So budget is, to me, subjective. I have customers who use titanium zinc, customers who use copper. And I can tell you, I have customers, bungalow, who use copper. And in my mind, when I saw the design, it was so modern, so contemporary, full of glasses. I thought it must be a young couple, right? It has to be somebody very young, maybe a yuppies, right, who's rich enough to build a bungalow. And to my surprise, it was a retiree couple staying in. It's so super contemporary, and you can see through from outside. And I mean, I can't imagine, elderly couple opting for such design. So it must be coming from the architect, how he convenes from design point of view. So to me, budget is very subjective, is how you convey the design, the message, and if they buy in, the budget is set from there and not, it's all about cost. I mean, sorry to say, QS is about cost. And I always tell them, as a QS, you don't just manage from cost, you manage from performance aspect, not just cost. Thank you.
I think that is one of the points that is very important for young architects. Because sometimes we don't understand the material itself. We don't know how to manage in terms of cost in overall of the project. So that's why we intend to give more for everything. But there's something that we can manage with make it more efficient in terms of cost. All right, so do we have any?
Can I add something
yes,
to that? I think one of the problems we find with steel structure costs, I find that our engineers here are not very well versed with the Euro code. Eurocode is what makes Foster and Herzog de Meuron look like God, you know. Everything is very minimalized. I have done sports centers and so on, and I just do a veranda, and I go to the site, I look at the steel purlins, and I said, the structure like rafters, I said, wow, that one, you can spend 40 meters, man. And I don't know why, and they always tell me they are afraid of uplift. And I think that if I don't know how to solve this thing, is to do with the engineering side. That look at the Kempsey house, it's got really minimal size structure. And if you look at Siksan Sekeping, it's been there for 20 over years, 30 years. And you look at the steel members, they are so slim, you know. And I'm always looking at mine, and I don't know why my engineer, you should never trust the engineer, right? I can almost half the size of every member. And not to say bad things about them, but I think the Eurocode made it possible for them to slim things down. And that's why we cannot beat people in stadiums, we cannot beat people in airport design, because our members are just too big. And Foster just continues to do almost floating structures. And I think that's an important element, and that's where I believe a lot of cost is. Not so much in the insulation, the roof and all this, the cladding, already bare minimum, MS 1525 to achieve it. We already milked it to the minimum. Then you look at where the cost is, I always see it in the structure. I don't know why our structures are so big. Solution, maybe we should run a competition for engineers.
We see who winning it. All right. Sometimes probably thinking simple works better than make it more complicated, right? Okay, so do we still have any questions from the floor? Our audience today is very quiet. Okay, never mind. I just want to promote one of our programs for PAM graduates. We are having an expert lead where we bring architects to factories. And our next expert lead, we also joining up with SISMA and Dusko in April. So look forward for that because it's limited seats. We're open for especially graduates because we want to give more information in terms of technical so you could help the company more and give more understanding, especially to the young architects. But as long as you graduate architects, not AR, you're still eligible. But we do have registered great architects that come in. And they said it's very practical because you can understand the material better and you can specify in your contract better. All right, so if there's no any questions, I would like to end our session today. And please scan this second QR code outside of the sign out before leaving the event and fill out the form. Please be in mind that will be a proof of your CPD point. We would like to thank everyone to join up today and have a safe journey home. Thank you.
Merry
everyone.
Christmas, Happy New Year.